Welcome to Bethlahem Institute of Engineering. Bethlahem Institute of Engineering is affiliated to Anna University, Chennai and approved by AICTE, New Delhi. This institution was established in the year 2008.
Principle of superposition. Sometimes a body is subjected to external axial forces, not only adjacent but also at the same of its interior cross section along the length of the body. In such cases, the forces are split up and their efforts are considered on individual section. The total deflection is equal to the algebraic sum of the deformation of the individual section. This principle of finding out the resultant deformation is known as principle of superposition. Okay, here the change in length del L formula is P1 L1 plus P2 L2 plus P3 L3 etc. divided by A. Okay, here let me see the one problem. A steel rod of 50 mm diameter is subjected to a force as shown in figure. Here we want to find the elongation of the rod and E equal to, E means Young's modulus, E equal to 2 into 10 power 5 Newton per mm square. Okay, then see the diagram. Here we have three sections, section AB, section BC and section CD. Okay, at section AB there is two loads are acting, 12 Newton and 2 Newton. The length of the section AB equal to 1500 mm. Then take the section BC. Here the two loads are acting, 2 Newton and 4 Newton and the length is 1000 mm. Then take the section CD. The length of that section is 1500 mm. Then loads acting are 4 Newton and 10 Newton in the section CD. Okay, here in question they are given the dia of the rod is 50 mm, 50 mm throughout the section, throughout the rod. Okay, throughout the rod. For both the three sections the dia is 50 mm. So area A equal to, it is a circular rod, so we are taking pi by 4 into d square. Here d is 50 mm, so pi by 4 into 50 square. Our area is 1963.4 mm square. Okay, then write the given data, length 1 L1, L2 and L3. Then Young's modulus for steel is capital E equal to 2 into 10 power 5 Newton per mm square. Okay, here we want to find the elongation of the rod del L. Okay, elongation of the rod del L. Then listen the diagram. There are two types of forces are acting, loads are acting. Okay, loads are force acting, tensile and also compressive loads. Okay, tensile load and also compressive load. Tensile load we are taking as positive and compressive load we are taking as negative. Okay, tensile load are considered as positive and compressive load are considered as negative. First take part AB. Take the part AB. Okay, listen. Take the part AB. In AB, first you take the left hand side. Left hand side there is only one load, 12 Newton. Okay, the load is compression, so we are taking the load is tensile, so we are taking as positive. So left hand side force is 12 Newton. Then consider the right hand side. Right hand side there is three forces. first take 2 Newton. Okay, 2 Newton. It is a compressive load, so minus 2 Newton. Then next take the 4 Newton. It is a tensile load, so plus 4 Newton. Next 10 Newton. It is also a tensile load, so plus 10 Newton. Okay, then minus 2 Newton plus 4 Newton plus 10 Newton equal to 12 Newton. So from section 1, that means the section AB, the load acting is 12 Newton. It is a tensile load. Okay, it is a tensile load. Then consider the part BC. Consider the part BC. Here, okay, consider this part BC. The left hand side of the BC is there is 2 loads are acting, 12 Newton and 2 Newton. Okay, 12 Newton and 2 Newton. The both loads are a tensile load, so we want to take as positive load, 12 plus 2. Okay, 12 plus 2 equal to 14 Newton. So left hand side we will get 12 Newton and right hand side 4 Newton plus 10 Newton. This 4 Newton is also a tensile force and 10 Newton is also a tensile force. So 4 plus 10 you will get 14 Newton. Okay, then take the third diagram. Third diagram CD. CD. Take this CD section. Take this section. In left hand side you will have 3 forces, 12 Newton, 2 Newton and 4 Newton. Here 12 Newton is a tensile load, 2 Newton is a tensile force and 4 Newton is compressive force. Okay, so 12 plus 2 plus minus 4. 12 plus 2 plus minus 4. So 12 plus 2 plus minus 4 equal to 10 Newton. Okay, then in right hand side there is 10 Newton. So the load acting on the section CD equal to 10 Newton. Next, okay, listen. Now we know the load P1, P2 and P3. Next we want to find the elongation del L. Elongation del L. Here we have 3 sections. So the elongation formula del L equal to P1 L1 plus P2 L2 plus P3 L3 divided by AE. A is the area of the section and E is the Young's modulus. Okay. Here P1 value is 12 Newton. Okay, so substitute that 12 into length L1. L1 value, L1 is 1500 mm. Okay, then next P2 value is 14 Newton. Then L2 value equal to 1000 plus P3 value 10 into L3 value 1500 divided by the area. Area you know, it is a circular rod, so pi by 4 into d square. Okay, so 1963.4 into E value, Young's modulus for steel is 2 into 10 power 5 Newton per mm square. Okay, substitute all values and find the elongation del L. So the answer del L equal to 1.196 into 10 power minus 4 mm. Okay, then let me see the second problem. Here a member ABCD is subjected to loading as shown in figure. Here we want to determine the elongation. Okay, elongation means the change in length due to the deformation of the bar. Here E equal to Young's modulus of the steel is a constant value. It is 2 into 10 power 5 Newton per mm square. Okay, here there is a 3 section. Here also we have 3 section A, B, C and D. Here in last problem the area is same for the 3 section. Okay, throughout the bar the area is same for the three section. Here area is changed for all the section. Okay, here for first section the area is 900 mm square, second section the area is 400 mm square, and third section the area is 625 mm square. Okay, here first you take the first section AB. Here the area is 900 mm square and the length is 1500 mm square. Okay, in this problem also you want to find the del L value. Okay, change in length or elongation, del L value. For that you know the formula, del L equal to P into L by AE. Okay, first you want to find the P for section AB. Here you take the readings for left hand side and right hand side. For tensile load we want to take the positive symbol, and compressive load you want to take the minus symbol. First you take the left hand side. It is 120 kilonewton. 120 kilonewton, it is a tensile force, so plus 120 kilonewton. Then take the right hand side. Right hand side you have 3 load, 50 kilonewton, it is a tensile load. Then 150 kilonewton, it is an compressive load, and 220 kilonewton, it is a tensile load. So tensile load 50, take plus 50, then minus 150, then plus 220. Okay, you will get 120 kilonewton. So consider the part AB. The left hand side reading is 120 kilonewton. It is a tensile load, so you take as plus. Then right hand side load 50 kilonewton minus 150, then plus 220. The answer is 120 kilonewton. So our P1 value is 120 kilonewton. Then consider the part BC. Okay, take the part BC. Here the area of the BC is 400 mm square and the length is 1000 mm. Here first you take the left hand side reading. You have two forces acting. One is tension force and another one is compression force. Here tension force is 120 kilonewton, compression force is 50 kilonewton. So 120 minus 50. Okay, you will get 70. Then take the right hand side, 150 kilonewton and 220 kilonewton. Here 150 kilonewton is a compressive force and 220 kilonewton is a tensile force. So 150 minus 150 kilonewton plus 220 kilonewton, you will get P2 value equal to 70 kilonewton. Okay, next consider the third part. Consider the third part CD. Here in CD the area is 625 and the length is 750 mm. Okay, the length is 750 mm. First you take the left hand side. In left hand side there is 3 loads are acting. One is 120 kilonewton, another one is 50 and 150 kilonewton. So plus 120 minus 50 plus 150. Okay, you will get one value that is 220. 120 minus 50 plus 150. Then you want to take the right hand side. In right hand side there is only one load, just 220. It is a tensile load, so we are taking as plus 220 kilonewton. So our P3 value is 220. Now you got the value P1, P2 and P3. Then just find the elongation del L. Okay, elongation del L formula P1 L1 plus P2 L2 plus P3 L3 divided by AE. Okay, then substitute all the values in del L formula. Del means elongation, or change in length due to the deformation of the bar. Okay, when we are applying the load, the member is undergo the deformation. That deformation we are considering as an elongation or change in length del L. Okay, here del L equal to P1 L1 by A1E plus P2 L2 by A2E plus P3 L3 by A3E. Here in we will get P1 equal to 120 kilonewton. We want to convert the kilonewton into Newton. So 120 into 10 power 3 Newton. Okay, kilonewton, converting kilonewton into Newton means into 10 power 3. So we will get 120 into 10 power 3 Newton. Then P2 equal to 70 kilonewton is converting into 70 into 10 power 3 Newton. Then P3 equal to 220 kilonewton. Converting into Newton means 220 into 10 power 3. Okay, then substituting the P1 value 120 into 10 power 3, L1 equal to 1500 divided by area. Area for section AB is 900 mm square. Next, Young's modulus for steel rod is 2 into 10 power 5 plus P2 value 70 kilonewton. Converting kilonewton into Newton means 70 into 10 power 3 into L2 value 1000 divided by area. Area 400 mm square. So 400 into E value, Young's modulus value 2 into 10 power 5 plus P3 value. P3, the load P3 equal to 220 into 10 power 3 into L3, length of the section CD, 750 divided by area 625 mm square into Young's modulus 2 into 10 power 5. Okay, next simplify this value, you will get 3.195 mm. So the change in length or elongation value is 3.195 mm.